Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Welcome. Thank you for tuning in. This is Mr. Simon, and we are here to cover Unit 3 of Senior 6 Chemistry, and we are going to be talking about fertilizers. We are going to be talking about fertilizers. So, Lesson 2 is about manufacture of fertilizers, and we are going to see how we can make our fertilizers. Actually, we are supposed to be talking about NPK fertilizers. That is fertilizers containing nitrogen, phosphorus, and potassium. So, as you hear the word fertilizer, it makes our harvest fat. It makes our harvest fat. So, let's continue. And we talk about the different ways how we can obtain our fertilizers. So we are going to be talking about the nitrogenous fertilizers, the N fertilizers, the P fertilizers, and the K fertilizers. So we going to first talk about nitrogenous fertilizers. And some of our nitrogenous fertilizers, we have many, but we are going to basically talk about 2 or 3. So we can first look at them here on our blackboard, then after we go back to them on our slides and we pass through very quickly. So we are going to be talking about how we can make the N fertilizers. N fertilizers. So the word fertilizer, it makes our crops fat. Okay, so we have here, we're going to have the first one we may talk about is ammonium sulfate. Ammonium what? Sulfate. Ammonium sulfate can be got from ammonia. Ammonia from the Haber process, and sulfuric acid from the contact what? Process. It is good when these industries are close together, and then they can produce ammonium what? Sulfate, which is our fertilizer containing what? Nitrogen. We can even calculate the amount of nitrogen in our ammonium what? Sulfate. Normally it gives us the percentage of nitrogen. And that's why we have some numbers on our fertilizers, as we are going to see. The second one we can talk about is ammonium nitrate. Ammonium what? Nitrate. So as you see here, we have ammonia and the nitrate. Normally is obtained from ammonia, which is from the Haber process, and the nitric acid from the Ostwald's process. Hence we produce ammonium what? Nitrate. So ammonium nitrate, obviously, it shows that it can have more of our nitrogen compared to this one, but also proven by calculation. It can be proved by calculation. Another nitrogenous fertilizer which is very common is urea. Urea, if you look at urea, it looks more of an organic compound. It looks more of an organic compound. So we have this NH2. NH2. So someone may ask you to give the organic name for urea. Maybe you can call it aminomethanamide. Methanamide. So we can produce it as an organic compound from this one. For example, if we have this, but basically is obtained from methane, as we saw in Senior 5. So we put 2, then we can replace our acid chloride with the ammonia. Then we shall have our urea plus 2 molecules of what? HCl. So these are some of our nitrogenous fertilizer. Another example of a nitrogenous fertilizer can be calcium nitrate. You can call it D, or we shall just talk about this one, calcium what? nitrate. But this one is obtained as a byproduct from different ways. Then we are also going to be talking about how to obtain the fertilizers. So fertilizers are normally those fertilizers containing potassium. So we have an example of potassium what? Chloride and the potassium what? Sulfate. Potassium chloride and potassium sulfate. So if you have this, they can act as fertilizers. Or you can have this, isn't it? And then you combine it with, for example, sulfuric acid, and then you form potassium what? Sulfate, which has more amount of potassium compared to this one. Plus what? You can say plus HC. Plus HCl. We can balance, or it may not be very important to balance, but it's good to when we balance. So we put 2 and 2 there. So, fertilizers. Then we can also talk about the phosphorus fertilizers. Phosphorus what? Fertilizers. As we are going to see that most of our phosphorus fertilizers, or the P fertilizers, they come from this rock phosphate. The rock what? Phosphate. That is the calcium phosphate. Here we put 3, and here we put what? 2. So we get this calcium phosphate and react it with our acids. We can react it with the different types of acids. Like for example, we can get this and react it with for example, phosphoric acid, as we are going to see in our slides. Then we can get calcium phosphate and react it with so they do normally do some controlled reaction, not as the ones we are talking about here, but let's just use them as examples. So we can also have plus sulfuric acid, sulfuric what? Acid. We can also have calcium phosphate, our rock, under controlled addition, and we react it with nitric what? Acid. We can also have calcium phosphate, calcium what? Phosphate, and we react it with, for example, another strong acid, HC. Then we produce our products. So those products will be fertilizers. Like for example, under controlled addition, here we shall form calcium. Normally we are interested in this calcium hydrogen what? Phosphate. Calcium hydrogen what? Phosphate. We normally do like this. Put 2. Put 2. And here 2. So calcium dihydrogen what? Phosphate. Then here it has lost 1. It has lost 1. We also have this one again. We have calcium again here. Phosphate again. We can put 2 here plus our calcium sulfate. Which we normally call gypsum. And we have also another one, which is under controlled addition. We can also have calcium hydrogen what? Phosphate. 2 plus what? Plus plus calcium nitrate. Calcium what? Nitrate. So we can also have calcium hydrogen what? Phosphate. 2 here plus obviously calcium what? Right. So all these ones will give us, will be, the products will be the phosphate what? Fertilizers. So we are going to see how we balance in our slides. Then we can also have another one we normally call DAP, which is DAP, which we call diammonium phosphate. Ammonium what? Phosphate, which is actually obtained from the reaction of our ammonia. Can use ammonia and phosphoric acid. We can use ammonia and phosphoric what? Acid. So we can say diammonium means they are supposed to be two. They're supposed to be two. We put 4 here. Let's use our duster. Put 4. So we put 4 here, diammonium. And say diammonium phosphate. It's supposed to be hydrogen phosphate. So we put our phosphate in here. Instead of 3, it's supposed to have 2. So we are going to do like this. 2 minus ammonium phosphate. So we can put 2 here. 2 there. So let's look at our slides and see how these things move on very well. So we are now going to go to our slides, and we have here, going to pass through what we have seen and try to make a better illustration. So nitrogenous fertilizers, we have given an example of ammonium sulfate, which is obtained from ammonia and sulfuric what? Acid. There they are trying to give you the amount of sulfuric acid which is added. In ammonium nitrate, we use 60% nitric acid also. See how our ammonium nitrate. So this is an example of ammonium what? Nitrate. The color is like this, but sometimes we get our ammonium nitrate mixed with the calcium what? Carbonate. Then we get what we call calcium ammonium what? Nitrate, which we call nitrate chalk. It's also a good source of what? Nitrogen. A good source of nitrogen. Then let's look at urea. Urea, an organic compound used as a fertilizer. Maybe you can call it an organic fertilizer. So you see, it can be obtained from ammonia, carbon dioxide, or the other acid chloride, even other things like methane. Yeah. So this is how our urea looks like. It is in form of, most of you, I know you've seen urea. It's in form of small particles which look to be having a lot of water. So this is an example of a bag of urea. 46 is showing the amount of nitrogen in urea. Actually, urea has almost the highest percentage of nitrogen in among our fertilizers. So, but it depends again on how much you've added. So then the others are 0. That is, if it is urea and NPK, it means the phosphorus is 0 and the potassium is what? 0. Then we have been talking about the K-type fertilizers, basically which add the potassium in the soil. So we have potassium chloride, potassium sulfate, and we've seen how potassium sulfate can be obtained from potassium what? Chloride. So this is an example of our phosphorus fertilizer, of potassium fertilizer. But you see it is potassium nitrate. If it is potassium nitrate, it means it contains, if it is NPK, it means it contains a given amount of nitrogen, no phosphorus, but we have potassium. So you see you have here like 15, here 46. So it's an NPK. So we can calculate those percentages chemically, like the percentage of our chemicals in these what? Fertilizers. So let's also talk about the phosphate fertilizer. As I've been telling you, that the phosphate fertilizer comes from, you say, are fertilizers which supply phosphorus as a major nutrient to the soil. And basically, as you've seen, we are trying to represent the most of the compounds we are trying to get is actually calcium. We have calcium hydrogen phosphate, calcium hydrogen what? Phosphate. Then, and we have been saying that this calcium hydrogen phosphate is coming from calcium phosphate, commonly known as rock phosphate. So this is an example of rock phosphate. Rock phosphate, we have many, depending on the country. So as we are discussing also at the beginning of our topic, we try to talk about the different types of fertilizers, the natural fertilizers, that the organic fertilizers. We also gave an example of rock phosphate. It can also be a source of what? Of phosphate. Or can be a source of what? Phosphorus. So this calcium phosphate is not soluble in water, hence it cannot supply nutrients to the plants. So what we need to do, we need to convert it to a substance which is soluble, like for example, calcium dihydrogen what? Phosphate. And most of the chemical reactions we have seen here, we are trying to see how we can convert this calcium phosphate. Let's look at our slides. This calcium phosphate to a soluble substance. So some of these soluble substances, that is, these minerals are therefore converted into soluble materials by reacting them with phosphoric acid, sulfuric acid, nitric acid, hydrochloric acid to form what we call the superphosphate, triple superphosphates, and the nitrophosphates, as you're going to see in our examples. So the first example we have here is calcium dihydrogen phosphate, which is actually can be obtained from, as we have seen, this time the equation is balanced. Our equation is balanced here. So calcium phosphate plus phosphoric acid giving us calcium dihydrogen what? Phosphate. Then we can also use, instead of calcium phosphate, we can also use calcium hydroxide, calcium carbonate, that is our limestone, to be able to form the same compound. This is also known as the triple superphosphate, like we have seen in our illustration here. Then we also have another fertilizer here, which is obtained from the reaction between, we have seen it, calcium phosphate and sulfuric acid to get calcium dihydrogen phosphate and also calcium sulfate. You know, sulfur is also important to so it's a secondary nutrient. So this type is called the single superphosphate. We have some examples here. You can look at their color. Normally they have this color here, single superphosphate, single superphosphate. These are the examples of bags containing single superphosphate. Then you also have calcium dihydrogen phosphate nitrate. This is obtained from the reaction between calcium phosphate and nitric what? Acid. This is also can be called calcium superphosphate nitrate or the nitrophosphate. So you observe it is having phosphorus and also is having nitrogen. So it can also be a source of what? Nitrogen, meaning in its percentage we shall have, if it is an NPK fertilizer, we shall have a percentage on nitrogen, a percentage on phosphorus, and 0 on potassium. So you've seen how it is obtained, and this time our equations are balanced. So we also have DAP here, diammonium hydrogen what? Phosphate. Diammonium hydrogen what? Phosphate. So here, we normally call it DAP. We don't normally mention the hydrogen. So diammonium hydrogen phosphate is also obtained by reacting ammonia from the Haber process and the phosphoric acid. phosphoric acid. So it is a good source of both nitrogen and the phosphorus. So it is similar to this one, source of nitrogen and the phosphorus, source of nitrogen and the phosphorus. So an example of DAP is this one. You see we have a percentage on nitrogen, a percentage for phosphorus. If potassium was there, it will be 0. It will be 0. So you can go to the market and get some of these fertilizers. But before you go to the market, it is good for you to make research on your soil and what you're going to plant, and then you try to compare the need of the plant, what you have in the soil, then you know what percentage of nitrogen and what percentage of phosphorus you need to add to your soil. So let's quickly go and talk about, as we try to conclude our topic, we are going to talk about the dangers of substandard fertilizers. That in case you go to the market and you buy a fertilizer which is out of date, or you buy a fertilizer which is named poorly, you will have some problems, obviously. So, as we have said, our topic is actually it's not all about all fertilizer. It is all about the NPK fertilizer. If it is an NPK fertilizer, normally they have ratios. The first ratio stands for the percentage of nitrogen. And how do you get this percentage? Obviously, you should know the amount of nitrogen you've added inside. Like, for example, urea. Then, after doing that, it is normally put even on the label you put on your fertilizer. If you are somebody who is in charge of making what? Fertilizers, then you should know the amount of phosphorus in your phosphorus fertilizer you've put. For example, if you've mixed, for example, DAP, you should know the amount of phosphorus which is there. Like this time here, the amount of our phosphorus which is there is 46. So you see, after the calculation, and we can do this in molar concept, though we are not going to do it here because of time. So this time, this fertilizer has 16 amount of nitrogen, then phosphorus is 0, and potassium what? 0. So supposing this fertilizer is labeled, instead of being labeled like this, it is labeled like this. So if it is labeled like this, yet it has this, you'll observe that if someone buys it and puts it in the soil or adds it in the soil, you'll get somewhat problems. Some of those problems are the ones we are going to look at. So dangers of using substandard fertilizers, or dangers of using excess what? Fertilizers. Actually, it is like the dangers of using inorganic fertilizers. So one of the dangers, it causes soil pollution, which leads to acidic or basic what? Soils. Like some of the ammonium ions, when they remain in the soil, they undergo hydrolysis, and after undergoing hydrolysis, they produce acidic what? Soils. So it also causes poor plant growth, poor growth of what? Plants. So poor growth of plants. It can cause a poor harvest. For example, if you want to produce a high yield of crops and you buy a substandard fertilizer, it will obviously cause a poor harvest. Then eutrophication, which we said, you can define for us eutrophication. Yeah, we said eutrophication is the existence of excess nutrients in our water bodies as a result of runoff from the land. Then we can also have fertilizers burning or scorching our crops. So let's look at some of these things we have. So these examples are trying to show us the ratios. You see now, like this fertilizer is having 20% nitrogen, 10% phosphorus, and 5% potassium. So someone may ask himself, why isn't, like for example, this NPK fertilizer having a percentage of 100%? No, the remaining percentage will stand for the other elements which are part of our fertilizers. So these are some of the percentage. Here we have no potassium, no potassium. So here we have an example of eutrophication. You see, eutrophication is somehow dangerous. You see, it leads, as we said, it leads to the growth of algae on top of water bodies. So these are all algae. So these are children trying to enjoy the algae, but I know it has a bad smell. Bad smell. So as a result, it causes death of water animals like fish, bad smell, and you observe that some people are supposed even to migrate from that place. Then here we have an example of fertilizer ban, a situation where our fertilizer bans our crops. You see now they are turning to brown. They are turning to what? To brown. Yeah, this is an example of using of excess fertilizers or use of fertilizer which is substandard. So it will burn. Now this wheat is undergoing, it is breaking down because of use of substandard what? Fertilizers. So in order to reduce the effects of substandard fertilizers, we can carry out the following measures. If, for example, you study and you become someone who is in charge of agriculture in a district or in a country, or you become our agriculture minister, you can apply some of these things we can talk about. Even other things we may not talk about today because of time. So first thing, we should standardize our fertilizers before we make sure we help ourselves with the RSB, and helps us to standardize or check on the fertilizers which are on the market. Then production of fertilizers in Rwanda, therefore RSSB can easily check them. And also before they enter the country, we carry out that check before they enter our countries. Then use of chemical fertilizers with coated what? Pellets. I have an example here of coated pellets. Yeah, coated pellets, as we've seen in our example, it's so that nutrients are released slowly. And this also prevents leaching. Yeah, you see this is an example of a coated pellet. This is a coat, and this is a fertilizer. So you'll observe that as it is working, it releases the nutrients slowly to the soil. And this is another example of a coated what? Pellet. Then another way, you can carry out regular watering. Yeah, in case you've used the substandard fertilizer, you can water such that they can leach, which will also cause eutrophication, which is not good. Also, we can encourage farmers to use organic fertilizers, like this one, our manure from cows. We can also encourage farmers to stop the use of substandard fertilizer. But this one can be helped by the police and the authorities, which can help to research or to look at the shops where they are selling fertilizers. They try to check the standard of the fertilizers. If they are substandard, they remove them and they ban them or they put them somewhere. Then also we should teach farmers the use of fertilizers. Like now we are learning about fertilizers. I learn from you and you also learn from me. Then also we teach our farmers. If I'm a farmer, I have a knowledge of fertilizer, it will be very good. It will be very, very good. So this is all about fertilizers. What we have not talked about in this topic, we shall talk about it next time. So we are going to look at some questions here, sample questions. So you try out these questions. So the chemical plant for manufacturing ammonia is often on the same site as plants manufacturing nitric acid and fertilizers. What advantages will this have for the manufacturing company? Yeah, you'll try to look for the answers. Using equations, show how the ammonium nitrate is obtained from nitrogen what? Gas. So you can write the equation here. I can help you. Nitrogen plus hydrogen, ammonia. Ammonia plus nitric acid, ammonium nitrate. So you write it. Then describe the environmental impact of such plants on the surrounding what? Area. What is the environmental impact of these plants here? Not the plants, but these plants which produce the factories. Then give 2 ways in which such impact can be reduced. Then number 2, sulfuric acid reacts with ammonia to give ammonium sulfate. Write the balance equation for reaction write the property of ammonia, what property of ammonia is shown in the reaction above, you try to look at, then you try to carry out this calculation. It will help you to know, let's say, calculate the maximum mass of ammonium sulfate that can be obtained from 100 grams of ammonia. So you can calculate also, that is more concept, then state the large-scale use of ammonium sulfate. I think we have talked about today. So you try out those questions, even other questions, which you'll find in your syllabus book. Thank you very much for following. Thank you very much for following. Hope you've learned something today. I know you've learned something about our fertilizers and NPK fertilizers, so you can apply the same knowledge if you become a farmer or if you are a farmer. God bless you very much. See you next time.